Welcome back. In this video, we'll be understanding about what is an ORM, why ORM, and how we can use Hibernate as a ORM. If you take any application, your application will be layered. The downmost layer being the data access layer, above it will be the service layer, and above it will be the presentation layer. In data access layer, we'll be having all the code to interact with the database. Assume that I am writing an application for a bank, and in bank they maintain all the account related details in an account table. So corresponding to account table in my application, I might be having a class called as account.java. This account.java we call it as domain class, and this domain class is shared by all the layers of your application. Now, in this data access layer, there might be code which will fire queries on database and populate your domain objects. Suppose if you are writing JDBC code, of course, what you do is you write SQL queries to execute and fetch the data and then populate the domain object. But as an object-oriented developer, we are not comfortable thinking in terms of tables and their relationships. For an object-oriented developer, we want to treat everything as an object. It will be good if we can represent a table in database as an object in my application. So we want some frameworks which can map tables in the database to our domain objects. So what we need is we require an ORM, object to relational mapping frameworks, which will map relational tables to objects. And there are a lot of ORM frameworks in the market. Among them, Hibernate is one of the ORM. There are other ORMs also like Eclipse Link, Top Link, OPN JPA, etc. Here we are going to understand about Hibernate as a ORM. Okay, so now we understood what is ORM, but now why ORM? If I don't use ORMs, what are the problems I'll be facing? Let us see. What is actually a mismatch between a relational world and object-oriented world? Let us discuss. So the first problem I could discuss is granularity. Suppose if I am writing a domain class called as account, let us see how to do it. Suppose if I am writing an account class, I'll write like this: account. It contains, say, account number and other fields like account name and all, and it may also contain city, country, state, zip, etc. As an object-oriented developer, when designing such a class, we don't want to keep all the properties related to address in an account class. So we always prefer to have granular classes. So we would prefer having a separate class called as address, which contains all these properties, and in account class we'll just have a variable of type address. That means as an object oriented developer, we prefer granular classes. But since there are two classes right now, how to map these classes to database? Shall I have two tables, one for account and one for address? Okay, let's assume we have two tables, one for account and one for address. And in my application, suppose if I want to retrieve an account for an account number, say 100, do we need to join these two tables? Yes. So that means queries are becoming costly. So whenever we are mapping classes to tables, we need to think about performance also. But when we are modeling classes, we prefer granular classes. So this is one mismatch in object world and relational world. In object world, we prefer granular classes, but whereas in database tables, we don't prefer to have a table for each and every class. We need to take performance also into consideration when designing our database. So how to map in such scenarios is one problem which is addressed by ORM frameworks. Okay. The next problem is the problem of identity. In Java, object equality is different. We say that two objects are equal or identical if x equals to y, or we say that two objects are logically equivalent by using equals method. But in database, equality is always based on primary keys. That means, let us see, suppose if I have two objects in my memory, one object is not having account number set, account number is null, but one object has account number. These two are account objects, but one is having account number and one is not having account number, it is null, but all the other fields are same. In Java, it is possible that I might have overridden equals method saying these two objects are equal if these fields are equal. But according to database, these two objects are not equal because in database, object equivalence is always based on primary keys. So whatever we call as equal in Java may not be equal in database. This is one of the ORM mismatch. And another mismatch is about inheritance. In Java, we have inheritance. One class can inherit other class. But in database, can one table inherit other table? No. That is again one of the problem. How to map such inheritance is again a problem solved by ORMs. Similarly, in object world, we use composition. That means address can be inside an account class. Account class has a reference of address. But can we have a table inside another table? No. Then how to map such classes to tables? So this is again another mismatch between object world and relational world, and these ORMs like Hibernate have strategies for mapping them. And again, when it comes to associations, in object world we have unidirectional relationships and bidirectional relationships. But in relational world, the relationships are always bidirectional. What do I mean by bidirectional and unidirectional? Let me tell with an example. Let's take a simple thing. I have two classes, company and employees. Or let's take an example of one customer has many accounts. Okay, customer is a class and account is a class. So I want to have a scenario where one customer has many accounts. So I'll have set of accounts inside customer. And one account belongs to one customer. So one account class has a reference to customer C. Okay. Now, if I ask you what is the association of customer with accounts, you'll say one to many association. And what is the association of account with customer? It is many to one. So in this case, the association among the classes is bidirectional. Now, how do we map the tables? So this is a customer table and this is the account table. Say customer ID will be the primary key, account number will be the primary key. So one customer can have multiple accounts. How do we map them in database? Generally, whenever you want to map one to many associations, we'll have a foreign key always on the many side. So customer ID will become the foreign key here. That means, let's say we have a customer with ID 100. One customer with ID 100 can have multiple rows inside account table. So one to many. So if I ask you what is the relationship of customer with account, you say one to many. And what is the relationship of account with customer? It is many to one. So in tables, we have a bidirectional relationship as well now. Okay. Now consider, while modeling my classes, I don't want a variable of account. I don't want a variable of customer inside my account class. But in customer, I have set of accounts. So if I ask you, what is the association of customer with accounts? You'll say one to many. But what is the association of account with customer? No association. So in this case, I can say it is unidirectional one to many association. But what about the table structure? Table structure will be exactly same even though we have unidirectional unidirectional association in classes. And let's take another scenario. In customer class, I don't want set of accounts, but in account class, I have customer. So now, if I ask you what is the association of customer with accounts, customer class with account class, no association. But account class has a many to one association with customer. So again, here it is unidirectional many to one association. But whereas when we see the tables, table structure will be exactly same in this case also. So for database, always the relationship is bidirectional. But for my classes, the association might be unidirectional. So we'll see a lot of problems when we are mapping this unidirectional associations. We'll discuss about all these problems and how to solve them. ORM helps us in solving all those issues with various different strategies. So this associations also is one of the mismatch. So why ORM? ORMs like Hibernate can mitigate this OR mismatch. And also one advantage of ORM is they provide us with an object-oriented query language, which is very convenient for an object-oriented developer. So let me just tell you an example of how object query language can make our life easy. Let's take a simple example. Again, one customer, let's say, has many accounts, and account class has one customer. Suppose if I want to get customer with ID 100, and let's assume that customer with ID 100 is having 5 accounts. If I am firing a JDBC query, I'll fire a query something like this: select star or c dot star, or let's say select star from account A comma customer C, where account number is equals to customer dot whatever. So this JDBC query. So this query will result in how many rows now? I said one customer has 5 accounts. So if I'm firing a select query based on this 100 by joining these two tables, how many rows will I get? One customer has 5 accounts, so I'll get 5 rows. So if I'm using plain JDBC, I have to iterate over the result set and map all these 5 rows to a single object customer. It is very easy if we have to map one row to one object, but mapping 5 rows to one object is again a problem. I have to write a lot of code. But if you are using object relational mapping frameworks like Hibernate, they have a lot of good strategies, and we write a simple HQL like from customer C, where C dot customer ID is equals to 100. This is the simplest query which we do. So we will get the customer object automatically, and Hibernate will take care of all the mappings. So as an object oriented developer, I can just feel happy and I'm comfortable writing object oriented queries. We'll dig more into object oriented queries a little later, but this is one advantage of using ORMs like Hibernate. And again, ORMs like Hibernate provide a lot of fetching strategies to fetch the data efficiently. If I talk about Hibernate, Hibernate provides us two levels of caching. Of course, caching means they improve the performance. So two levels of caching can be provided if you are using Hibernate, which increases the performance. So hope you understood what are the problems, what are actually OR mismatch, and how ORMs can solve these issues. See you in next video on Hibernate. We'll practically write a simple mapping and I'll show you how to perform CRUD operations in my next video. See you in next video.